This is my first time in Boston and my first conference in Boston also, and this has been a blast. So huge shout out to everyone who has helped make this to be an awesome event. So yeah, seriously. So I'm here to talk to you guys about an awesome library that can let you create super awesome VR experiences in the browser. So if you're a JavaScript developer who is familiar with React, and you don't even have to be an expert on React. You could have learned React yesterday, but I'm telling you now, you can be confident that you can build three-dimensional, 60 frames a second, smooth, buttery rendering, virtual reality experiences in the browser, in the platform that we work in day to day. And that's pretty sweet, right? Like as a front-end developer, I don't really think about doing or building virtual reality apps. I mean, they seem cool, and I always tell myself, like, oh, I don't have time to learn Unity. I don't want to learn an entirely new tool chain to go and create something that seems as fun and as immersive as a virtual reality application and ecosystem. But I want to tell you guys that this is actually possible, and it's possible with React, and it's possible in the language that you write in day to day. So nothing new. We're going to kind of go on a philosophical journey of uncovering things we already know to show you that you can build a 3D app in VR if you wanted to, using only the stuff that you're already familiar with. We're not going to use, well, we will use one new library, but we're not going to use a new language or any of that. So who am I? Like I said, my name is Matt Hamil. I'm not related to Mark Hamill. He's the guy who plays Luke Skywalker. He actually has an extra L in his last name. But that's me on Twitter @_Matt Hamil. I work for a market research firm, 2020 Research, out of Nashville, Tennessee. You might not have heard about 2020 Research, but you've probably heard of some of the clients that we've worked with, like Amazon, Netflix, and Spotify. So we are very interested in consumer behavior and what really drives customers to use products, to buy products, and how do they interact with them? How can we uncover new insights for these clients to help them either refine their product, refine a marketing strategy or mission that they're trying to go on? And we pair with them, and we're always trying to uncover new ways to gather insights for clients. So for us, for a market research firm, VR presents a very interesting medium for us. I mean, you could imagine putting someone in a virtual reality shopping aisle and seeing not only what brands they're interacting with, but maybe making even heat maps of the brands, the icons on the boxes on the shelves that they're looking at. So that's, we don't use it quite yet at work, but it is an interesting opportunity for us. So like I said, we're going to start this off by really uncovering what we already know to learn how to make virtual reality apps in the browser. So let's start with some fundamentals. Everyone has probably heard of this term of thinking in React, right? I've heard a few speakers mention this phrase over the weekend if you want to build elegant UIs with React, we have to think in React. But what does this really mean? What does it mean if we want to think in React to build a component library or think in React to create certain animations on the screen? What are we ultimately doing? So React has two really powerful things about it that make it super awesome and great to build user interfaces with. The first is the immediate thing that you probably think of when you hear the phrase thinking in React. And I mean, if you've learned React a while ago, or if you learned it yesterday and were skimming through the docs, you probably came across the page in the documentation that talks about thinking in React. And they talk about sectioning these components, creating these components that do one thing, they do one thing really well. Say if I'm Twitter and I have my home page, I have my list of tweet components, which handle tweet logic and tweet things. It doesn't handle profile things. That's for the profile component, right? And these concerns do not cross each other, and the components can interact with each other, but a tweet component should not know anything about a profile, and vice versa. So we have this separation of concerns for our UI. But more than that, React is ultimately an abstraction that lets us render to anything. We have React DOM that lets us target the browser, right? I can write a div in my render method, and I'm expecting a one-for-one div that appears in the browser whenever that component renders and is mounted. But we've had some interesting technologies that have came out that use React, but they don't necessarily target the browser. If you've used React Native, you've used this in action, and you've seen it in action. So React lets us really ultimately target anything, as far as where it's going to render. So we separate the UI separation of concerns is one powerful abstraction that we can get from React, but we can also use that power to say, I want to just think about these components split up, but I can render them wherever I want to. I can change how, or change where I'm targeting. So ultimately, if we can do that with React Native and target mobile devices like Android and iOS, why not do that with VR? Why not do this in 3D, right? If I could take that same approach of building components and a user interface, if it's an interface, we should be able to use React to build it. So React 360 is a library out of Facebook and the Oculus team that lets us do this and lets us create virtual reality experiences in the browser. Again, which is awesome because we're used to this. We know the browser's quirks, we know JavaScript, and ultimately now we can create a 3D experience that anyone can enjoy if they have access to a browser. I don't need a VR headset necessarily. I can still create an immersive 3D environment for them, but using React and still thinking in React while I do that. So well, there's an image overlaying this one, so I'm gonna back up for a second. Oop, I just totally ruined, I should not have done that. Let me just go back to, let me unplug for just 1 second, because that is ruining my slide. Okay. Anyway, sorry about that. So I had another image overlaying this one that doesn't say React VR because that's the outdated name of the library. It's React 360. So anyway, what does this abstraction that React 360 uses to render 3D? And it gets kind of crazy. It almost feels like it's a hack and it shouldn't work, but it does. So React 360, formerly known as React VR, it actually uses React Native as its first layer of abstraction that's going to help us render in 3D. And you might be thinking, well, React Native is meant for Android and iOS and mobile devices, and this seems out of place to be rendering on the browser. But React Native is actually it has some tools in it that let you create native modules on mobile. I could create a Java module and connect it to React Native and say, this is a component, let's treat it like a component. Let's give it props, and I'm just gonna let you say, I'm just going to interface with this like it's a React component, but I'm gonna want this to appear in my DOM like any other component. So we can do this and give it other tools like Three.js and say, I want to render a Three.js component, but I don't want to do any Three.js code. I want to put this React wrapper around it. And I want to do that so I can just create a React application that we're used to. I don't want to have to go and create a Three.js module and then learn about linear algebra so I can learn about vectors and quaternions and three-dimensional rotations. These are all things that kind of sound scary and feel really daunting if you are wanting to learn about game development or virtual reality. But again, like I said, we don't have to learn anything new to build a virtual reality app. I mean, you can get really crazy with some animations with VR, but ultimately, it's a lot simpler than that. So we have React Native, which interfaces with an Oculus VR user interface library from the Oculus team, which also interfaces with Three.js, which is a 3D rendering library for JavaScript, and it also interfaces with WebVR browser APIs, which are in virtually every single browser nowadays. So if we wanted to create a VR app, we can target virtually any platform that we're probably already targeting with the modern 2D React applications that we are currently building. And ultimately, all of this is, of course, on the browser. So let's build our first 3D component. Let's build our first virtual reality app as a component, a single component, and this will be your first virtual reality application. So in React 360, like I had mentioned, that this uses React Native under the hood. If you've used React Native, you're probably familiar with the view component, which is just an abstraction over whatever platform you're targeting, and you're telling React Native, hey, I don't care if you're using a UI controller or if you're using however Android is going to create that view. I just want to create a view. So we're not caring what's underlying it. I'm going to wrap this with a view, so it's synonymous to like a div tag. Then I'm going to use a model, and I'm also going to import this from React 360. And models are just my 3D objects. This is my 3D primitive. And if I want to create an object, I need to give it an object file. I need to give it an object material. So these are things that, this is one of the new things that you would be exposed to building virtual reality applications. I'm not a 3D modeling expert, and I'm quite frankly not an artist, so I don't know how to create these myself, but there's resources out here if you wanted to create or find three-dimensional models out there. So I'm going to place a 3D model in three-dimensional space. Now, the first thing, before I talk about the next line where we transform it in space, I want to say that on the 2D, in 2D web, on the browser, we're used to things like display block for divs, or divs which are display block out of the box. So if I take a div and it's display block, and I want to render another div that's beneath it that is also display block, what do I expect to happen? I expect that second div to actually render below the first div, right? Like that's allowing me to create a natural flow of the page, and I can look at my markup and almost expect to see something. Like I can visualize it without actually rendering it to the page, right? But for 3D, we don't really have this idea of a document flow because 3D isn't a document, right? The web was initially built to show and share documents on the web, but with 3D, we don't have any of that. What kind of an assumption is it to make in 3D space if I say I want a box and then also another box, but also just stack them, right? Like that falls apart because then we might want to do other things. So using a 2D mindset, that 2D mindset of things should be stacking and flowing in a normal flow, we can't make that same assumption in 3D. So we have to absolutely position, again, it's not actually absolutely positioned because we don't have that concept of document flow, but we're going to position everything in three-dimensional space. We're going to transform this object by applying a translation to it. So translations on 3D objects are just an easy way to think about it is just saying, I want to put this in space. And I want to put this object in 3D space given a three-dimensional vector, which all that means is I want to give it an x, a y, and a z coordinate. So I'm just going to say, okay, I want to put this at 0 on the x-axis, 0 on the y, and -3 on the z-axis. The user is facing in the negative z direction, so I just want to put this box in front of the user. I just want to see something in 3D space. Then after we create our components, our application, our super awesome 3D app that we have, we want to register it. And again, this is a very similar API to React Native. And actually, this used to, before React VR rebranded to React 360 and they had a whole new update to the application, you used to actually import app registry from React Native itself, and the same as Vue. But now we're just registering it as a root of our app, and this will get painted to the screen, and then React 360 is going to do everything else under the hood so you can have a super awesome immersive 3D experience. So who wants to see what our first VR app looks like? Ooh, yeah, it's just a white box. That's it. That's VR. Y'all can go home. But no. So we can do better than this, right? Like all that we did was we just put a box in space, but it looks 2D. So we have to start thinking whenever we're building these VR apps, because it is easy for us to build these. It was just a React component. There wasn't really much going on, but I just put this in 3D space. So how can we make this better? we have to start training our minds a little bit and thinking, okay, well, what are some adjustments I could do to this? Again, this doesn't look 3D, but I could kind of hack that a little bit and say, well, what if I wasn't looking straight at it? What if maybe it was tilted down a little bit? That way I had like a perception of depth, right? We can do that. We can do this. We can take our cube, we could give it a color, we can put it in 3D space, again, like we've had. Maybe we could put a plane beneath it. That way it looks and feels like it's somewhere specific in space. And it's funny thinking about these things that we can do to three-dimensional objects as like, oh, this is a new way how I have to think and train my brain. But we all live in a three-dimensional world, right? Like this isn't new to us. So how can I make this more lively? And we just showed in the previous slide that excuse me, sorry, I need some water. I can position things in 3D space, but what's cool about that? You know, I could just have a white box on the screen, call it a day, push it to prod, and say I have a VR app, but we can animate these things. And that's probably the two most important things that you can do to create an awesome VR experience is that you can put it somewhere, but you can animate where you want to put it. So I could have a box that moves around if I wanted to have box world where the box just moves along each axis in space. But that's not really that great. Again, we can do better than this. And again, we're just building a React application. We're used to building and shipping React apps every day, but now we just have to, again, just think a little bit differently about this. So if it is just a React app, whenever I'm building one, I have to think of, okay, well, what does the structure of my app look like? How am I going to organize my modules? In a typical React app, you might have components that fall under like a container component classification, or these are ones that are connected to Redux. But ultimately, we come down to whenever we're building our applications in VR, we have slightly different concerns, but we can think about things in 3 different ways. We can think about objects that we're putting in space as part of the scenery, the 3D world that the user sees, but maybe not necessarily can interact with. So static objects like the grass, a bush, something like that, that we might not expect the user to actually do anything or gain any value out of interacting with, but it just adds to that immersion. We obviously also have a user, which the user is going to contain any logic and do anything that the user should do and can do. We also have the environment, and that is anything that the user can interact with in the three-dimensional world. And this is pretty obvious stuff, though. I mean, this isn't groundbreaking things, but again, we just have to kind of retrain or slightly shape how we are thinking about building a React application as we're building it in virtual reality. So let's look at a very simple 3D app example that I threw together. We're going to take Frogger and put it in VR. I obviously don't have a VR headset on, but with VR or with React 360, we don't necessarily have to create a virtual reality experience, but we can create a 360-degree experience that a user can access from a laptop, from a mobile phone, from a tablet, and we can do this with React 360. But it's even better if you do have a virtual reality headset on, because we do have APIs that can integrate with these input devices that do come from 3D or from VR gear. So you can see this, and again, this is all built in React. This is a React app that you can go home and build. So we have a 3D space. You can see I have some scenery. The user can look and turn around. You could imagine that if this was on someone's face, one of the VR masks, I could turn my head and look and see that everything looks and feels like this is taking up 3D space. It's not just like that white square we saw where it's just straight on. But what I can do with this is I can take the frog and get him across the street and score points. I mean, that is Frogger in its essence, right? Like the whole goal is to take the frog, get him across the street. But if I cross paths with the car, I have to start all the way over. I might lose a life if that was built in. But you can see that as I go across, once the frog makes it across the next time, boom, my score increments by 1. I'm also using local storage to cache the highest score, so that way you can gamify it. And if this was like a full-blown game that you shipped, but you don't have to only do games with React 360, I could tell my friends like, hey, I got whatever high score. But this is a very simple, a very straightforward React application at the end of the day. So let's actually take a look at that and see what the code looks like. So the first thing that we're going to do is we're going to look at can everyone see this, by the way? Can anyone not see it? Awesome. So this is our root file. This is our index.js. And like I had said before, we have this app registry module that we import in. And this is going to create our React roots. So in React 360, you might not necessarily have one React root for your entire app. Because React 360 is actually gets kind of crafty. You can have a root for your 3D objects, and then if you wanted a static 2D interface that might have buttons or might display a score or anything like that in your application, this is actually in a different React root, which makes sense because those things you might want on a 2D surface compared to 3D objects. So we're registering these different things here at our index.js. You can see that I have this object root, which is just going to contain all of our objects that we have. So you can see in the object root, I have a player object, and this is going to contain our logic for the frog and how it can move about, limiting it from doing certain actions and enabling it to do other things. We also have this car manager, which is just going to manage how all the cars work in the environment. And then we also have a scenery component, which this just renders anything that is not the user in the environment. So the trees, there were some flowers. So let's take a look at the cars, because this is really the meat of it is in here. So I have, and I'm just going to show you the render methods too, so I can just skip through all of this other stuff, and I'll have a link to the repo itself. But scrolling up. Okay, so we have this render method where we just have cars in state, and we're just going to iterate through these, and then we're going to render a car for every car in state. But what does the car do, right? Like the cars don't just do one static thing. Like they animate and move along an axis. So the cars will start at one side of the road and they drive and they make their way on the other side. So we can do this with animations. And if you're going to make a 3D app, this is probably what you're going to be writing the most, is just animation code. And if you have used React Native and are familiar with its animated API, you'll probably be happy to learn that it's the same API. And again, before React 360 was rebranded as such, whenever it was React VR, you didn't import animated from React VR, you imported it from React Native. So it's the exact same API. I'm going to give it a starting value, and then I just want to animate it to a value. So you can think about, instead of saying, I want the car to go, you could say that instead of saying, I want this car to go, whatever speed, I'm just really saying, how long should the animation take? That's the same way to think about movement in 3D. So I just take these cars and animate their location in space. Everything else is the same. Like the X value doesn't change, the cars don't swerve, the Y value is the same, the cars are in the same lane, they don't go magically elevate, and I'm just moving them along one axis. So ultimately, this is it. Like the other logic is just the fact that if the player's position in 3D space, if it makes it to the other side of the street, then we just get a point and move it back to the start. And we can all envision how that works in React, right? Like this is all just using set state, and everything else is just what we're used to. So let's talk about three-dimensional UX design. So we can use these things that we are already familiar with. We already know React. We already know JavaScript. We can go find some 3D models. We can go render them on the screen. We can animate them. We can make the user interact with them. But now that we can do that, now we're kind of responsible for how the user feels about this interaction, right? I can go and create a three-dimensional app, but I might make my user sick because I'm taking the camera and shaking it, or putting him on or her on a roller coaster simulator, and that's terrible, right? Like everyone's probably heard of simulator sickness when it comes to virtual reality, which is the concept of when you have a VR headset on, you eventually just get, some people report that they get motion sickness. So instead of just giving people an over-the-counter to treat that, because that's not really sustainable, right? Like every user, if they put on a VR headset, we can't really expect them to do that. We can just make a better experience for them. So the first thing that we can do is we can think about a user's field of view. And this is kind of like the same principle. You can think of all the concepts that we're going to talk about with a user's field of view. It's the same as, we're going to relate this to the 2D concept of above the fold. So for 2D web apps, we put the most important content above the fold, right? Like what does that mean? Like whenever a page loads, before the user scrolls, we should be displaying either the most important, whatever is critical for them to see, to have an awesome experience up front. That way we don't lose them within the first however many seconds of them interacting and using the site. So we should put everything up and immediate for the user to see. So with a 3D web app though, we don't really have this idea of a fold. We can't tell the user, or the user can't really say, hey, well, I can't scroll. I mean, because they can't. I mean, it's 3D space. So we have to kind of think in terms of okay, so what are the actual physical limitations of a user's vision? Like, how can we simulate that idea of putting the important content above the fold for a user, but in three-dimensional space? So we have this, if I am just staring straight ahead, right, 62 degrees to my left and 62 degrees to my right, that is my field of view. And of course, off to the sides, that is my peripheral vision, so I might not be able to recognize people who are sitting to my left and sitting to my right. But within, more narrow than that entire 124-degree cone, I have a smaller cone of about 30 degree, it's about a 30-degree angle that I have where symbol recognition takes place. And this is the concept of, if you're staring at something, you recognize it, right? Like if I have shapes off to the side, I might struggle with identifying what they are, but if I'm looking at a square head on, I can see that it's a square. So if we're taking this idea of above the fold and applying it to 3D, we really need to be cognizant and aware of the fact that a user's vision is, it's whatever, put what's important in front of them. Make it very clear. And don't put things off to the side, right? Like if I'm thinking of the stereotypical images of VR, you see these giant touchscreens where the user has to physically reach and touch buttons, or I want to touch and interact with a menu. But that's not necessarily a clean experience for them. For one, you're also expecting them to physically reach and touch things, and that's a whole other discussion of physical accessibility in VR. But let's put things clearly in front of them. And speaking of physically interacting with a three-dimensional world, everyone doesn't have these VR headsets. So it'd be crazy to expect people oh, I want to ship this VR app, but it's only really going to be usable if you do happen to have one of those. And that's not many people. But you can use VR web APIs to target laptops, phones, tablet computers, and we need to be able to have a concept of, we need to be able to, we're used to in the 2D web to have responsive design, right? We have 2D responsive design in our web apps, or at least we should, if we're expecting users to open the app on their phones. But we need to have the same mindset with building 3D apps and VR applications, because a user might not have that headset that has input devices, like gloves, or some VR headsets have these sticks where you interact with them and you can twist and turn them about, and your character in 3D space will also move their hands. But again, those input devices, they're not standard. One headset might wear gloves, another one might have something completely and entirely different. So, going on with this idea of physical limitations of a user, if we are putting interface buttons for them to touch and press, again, we need to put these close and around the user. If you have things that require them to reach around and touch an interface just to use your application, they're going to eventually get tired of using it. And if they get tired of using it, they're not going to use it again. And if that's the case, then your company is going to now lose money, and now you've just built a web application that's not very usable and doesn't give a great user experience for that person. So ultimately, what it boils down to is, we can use these technologies that we are already very familiar with. These technologies we work with day to day. We all work with JavaScript. We all probably work with React. You're at a React conference. So we can use that to build a 3D web app. But again, since we're now in a 3D world, we're now kind of responsible for our user's experience, right? Like, you are responsible. And the third dimension doesn't necessitate that. Like, if you were building a 2D application, you're also responsible for how the user feels that their interactions are with your website. You might think your web app is the best and the greatest. Your VR app could be awesome. Honestly, it could look awesome until the user starts to try to interact with it. And it could be terrible. It could be a terrible experience. So think about this. Accessibility doesn't stop in the second dimension. It's everywhere, right? Like, we should be able to see this in our every day-to-day life, right? So any kind of application you build, you're responsible for that experience as a developer, honestly. So all of this to say, we can take these tools that we know. We know React. If you don't know React, I encourage you, go home, read the docs, play with it. It's awesome. And honestly, give React 360 a spin, because you can surprise yourself with some of the cool projects that you can build. So thank you guys for letting me give a talk here on React 360. Hope you all have enjoyed the conference.